Okay, the last thing I want to do today, very quickly, is to talk about an even more optimized form of merge sort, which is essentially the bottom up approach. So, merge sort is a divide and conquer algorithm, which means that unlike decrease and conquer algorithms, we split the problem into two parts. Um, doing no work upfront. Again, divide and conquer is also of those two types. In quicksort, we do some work upfront, partition the elements around some pivot, and then we hand the left and right partitions to our subordinates, who then do the same thing. And so the sorting is happening in a the work uh, done in quicksort is happening in a top-down fashion. First, the root manager does the work, then the next level managers, and then the next level, and so on. In merge sort, though, we are waiting for our two subordinates to sort their subproblems, subarrays, before we merge them together. So everyone is doing the same thing. Everyone is waiting on their subordinates to sort the respective subarrays, and then only will they merge those subarrays together. And so, how does the work happen? Well, the people who are actually starting to do the work are the leaf level workers who actually don't do much work given that the subproblem size is small. But their next level managers, they will merge the two, sub arrays together, do some work involved in merging, and so on. Once they are done, their next level managers will take their, sub arrays, merge them together, and so on. So the merge work uh, is happening in a bottom up way. The bottommost level of the tree is where the work starts, and the topmost level is where it ends. And so, if what we had was an array that was to be sorted, we can imagine the leaf workers as working with subproblems of size 1 or 0, maybe 1 here. So they're not doing anything, but their managers are taking the uh, subarrays and then the subarrays of size 1 and then merging them together. And their managers will take the two subarrays size 2 and merge them together, and so on. So what if we take so can we write this in an iterative way? If we were to write this in an iterative way, what we would need to do is to simulate what's happening here in a bottom up way. So the leaf level workers work with um, arrays of subarrays of size 1. The red managers work with subarrays of size 2, and so on. So if we can start describing the work being done progressively up in this way somehow, we would succeed in doing merge sort. So how would we do that? So we have an array of size n from 0 to n minus 1. So initially the lowest level managers are actually merging together subarrays of size 2. Then their superiors are merging together subarrays into an output of size 4, then 8, 16, and so on. So that means at an arbitrary level here, we are taking two subarrays of some size. I'm just going to call this as step size, for lack of a better word. Step size starts out being 1 at the very bottom, then becomes 2, 4, and so on. So this is the left, this is the right part, or what was the left and right part in when we were thinking about it in a top-down way. And then likewise the next step size. I mean, we would have lots of these subproblems at the same level that we are trying to combine and merge together. So let's think about how we might write the code for this. The step size starts out being 1. That's the smallest step size that's possible. It's the largest step size that's possible. Well, this step size is going to keep growing, growing, growing. But if this left half, let's say, itself ends up spanning the whole array, and the right half is empty, then there's nothing to do at that point. So as long as the left half, uh, the left part and the right part both exist at any level, there is work to be done in in merging. So the step size starts out being 1, and what we can say is while the step size is smaller than, can it be equal to, uh, yeah, it can be, no, even if it's equal to, there's nothing further to be done, right? If the step size is equal to the length of the array, the whole array is sorted, that means at that stage. So as long as the step size is less than the length of the array, um, there is going to be a right sub array which will be merged in with the left. So while the step size is smaller than the length of the overall array, what we will need to do is keep merging consecutive uh, subarray pairs of length equal to step size, whatever that current step size is. If step size starts out being 1, that means we're merging together consecutive subarray pairs of length 1. We need to write the code for that in a left to right order. And then as step size grows from 1, uh, eventually the last line here is going to be step size is to be doubled. Right? Once we have described whatever is happening in that level in an iterative way, then we'll double the step size at the next level. Right? Once we've done with one level, we go to the next level where the step size doubles. So this is the code that we need to write. How do we merge consecutive subarray pairs of length equal to step size? So, and we might have to do that many, many times because in the same level, there might be many such subarray pairs. So, if let's say this value is first, this value is second. So, by the way, the code that I'm writing, it's idiosyncratic in that uh, there aren't any problems involving a bottom-up iterative implementation of a divide and conquer approach. This is probably the only one that at least we have in our curriculum. Um Unlikely that you will see this, but you know, just For completeness sake, I'm just writing the code for merge sort in a bottom up way. Quick sort, by the way, cannot be done in a bottom up way because, as you saw, the work is being done in a top down way there. So you can't really write that in a bottom up way. Whereas merge sort is inherently bottom up, so we can do that. So whichever subarray pair we are at, uh, let's say the left subarray starts at index first. That means the right subarray is going to start at index first plus step size, right? And the length of this subproblem is always going to be step size. The length of this subproblem will generally be step size, but if we are looking at the rightmost pair, it's possible that this might be shorter. So um, this is what we need to zoom into. Keep merging consecutive subarray pairs of length equal to step size. How do we do this? Uh, so I'm going to have my first variable and the second variable, which will start out being equal to 0 and being equal to 0 plus step size, which is step size. And then once we have sorted these are always sorted in a bottom up way. The left half and the right half are always sorted. We have to merge them together into a larger sorted section of double the size and then move on. Then the next subarray pair will be obtained by taking the previous pair and then adding 2 times the step size to it. Right? Same thing here for the second. But for a particular first and second value, what do we do? So basically I'm writing the code for this here. So we'll have first being equal to 0, second being equal to 0 plus step size, which is step size. And then while, how long do we keep doing this? While, um, both of these exist, both the left subarray and the right subarray exist. If it so happens that we move so far to the right that we only have a left value and no right subarray to merge it with, then there's nothing to do, right? So in other words, this second value has to exist, has to be a valid index. That's the point. As long as the second value is a valid index, we know that there are two subarrays to merge together. So while the second index is a valid index, that means it's less than the length of the array. What are we going to do? We have to do the work of merging together these two subarrays. Oops. These two subarrays into a bigger subarray. Okay, so we'll do the same thing. We'll have an I pointer and a j pointer. So the I pointer starts out at this first value, and the j pointer starts out at the second value, and they'll keep moving forward like that. I is first, j is equal to second, and as long as, so we have the same while loop, as long as the I pointer has not yet reached the has not yet jumped off the right edge, right? When it jumps off, it's going to equal to second pointer. So as long as while I is less than the second pointer, that means it's within the bounds of the left subarray here. While I is less than second pointer, and j is less than um, so it's possible that if this is the rightmost pair, then this second or the right subarray might not be of length equal to step size. It could be shorter. But if it's present fully, then it's going to have a size that is equal to step size. So this index, if it exists, the first index here will be whatever the second index here was plus the step size. So that's if the right subarray is present in full, that's what the value will be. So the j pointer has to stay less than second plus step size. That's the boundary for the j pointer. But if the array is actually shorter and it's cut off right here, we need to make sure it doesn't cross the right endpoint of the array. So I can capture both by saying j should be less than not just the length of the array, but also second plus step size. Second plus step size, and it should also be less than the length of the array. So that means it should be less than the min of these two. Okay. This is a little complicated, but um, hopefully it's making sense. So while I and j, but I mean, in terms of the template, this two pointer code is essentially the same. We are saying while I and j are still pointing within the respective values, uh, within the legal boundaries of their respective subarrays, we have the three cases in case of merge sort, essentially two, that if the array of I is less than or equal to array of j, since less than and equal to are treated in the same way, what do? We take uh, array of I and we are going to add it to an auxiliary output. Now, what is the auxiliary output? So I'm actually going to go with with the global auxiliary array solution that I had earlier in this class. So that way I don't have to keep creating, allocating and deallocating an auxiliary array. I'm assuming that if my subproblem is from start to end here, uh, my auxiliary array scratchpad will also be used from start to end, right? The same set of parallel indices. So um, when I start out here, I'm going to set my k index, which is the next place where the auxiliary array will go, to also be equal to um, where the I pointer started. So I can say k is first, or I can just set k is I. But remember, this is the index in the auxiliary array, not the original array. I is the index in the original array. So if array of I is less than or equal to array of j, that means I'm going to take the auxiliary space and at index k, I'm going to copy the value of array of I and then do k plus plus and I plus plus. Otherwise, if array of I is, if array of j is the smaller value, then I'm going to copy into auxiliary of k the value that was at array of j, then do k plus plus and j plus plus. So that's what we do when, as long as both pointers are pointing within their respective subarrays. Now, maybe one of the pointers jumps off its respective subarray, in which case we have the gather phase. We have the gather phase where we essentially have the same condition. Like while I less than second, suppose the I pointer is still within the legal bounds of its subarray, I'll do the same thing that I was doing in the body of condition here. So gather up the I values and increment k and I. Likewise, if it so happened that the j pointer was still within the legal boundaries of its um, subarray, I'm just copying that here from here. Then I'm gathering the elements from the right subarray into the auxiliary output. And then once the gather phase is over, then we have to copy back the values from the auxiliary output to the original array. Right? The original array had values from um first, the first index, right, from the first index to you should say index second plus. So this was second plus step size, right? This index was second plus step size. So up to second plus step size minus 1. This value will be second plus step size minus 1. So that's the last index unless the length of the array is less than that. That means unless this value lies beyond the length of the array and the right subarray is actually shorter than step size. So in that case, we would just again have a min of this and n minus 1 or length of array minus 1. Whatever the min of these two is, that's going to be the rightmost index. So leftmost index is first, rightmost index is this. And so for the same range of indices, we just have to copy the values from the auxiliary array back into the original array. So that's what I'll do here as the very last thing. Um, in the original array, so the valid range is from first to min of length of array minus 1 or second plus step size minus 1. This value is the same as the same index range in the auxiliary array. So we copy it back into the original array, and that finishes with our um, merge of these two. But remember, this is in a while loop because we have many of them to be done um, at that same level. Right? We're going across all the managers who are merging together subarrays of the same size here. So um, at this point, we will just maybe increment the first and the second values. So the first value would be uh, incremented by, so the first value needs to become this. So it's going to be incremented by 2 times step size. So step size is what this is. So 2 times step size, and the same thing with the second value. Right? The second value needs to become this. So it also needs to be incremented by step size plus another step size. So second value also becomes incremented by 2 times step size. And by doing so, it's possible that it might exceed the length of the array, in which case we'll exit. So this entire code, let me actually color code it in pink. This entire piece of code is going to fit here. So it means just outside the while loop here, when we exit, when the second value becomes greater than the length of the array, that means we reach the right endpoint here. We are going to uh, increment the step size, or sorry, multiply it by a factor of 2, indicating that we are going to the level above. So we do this, and once the step size becomes equal to the length of the array, that means it's not possible for there to be, um, it's not possible for there to be two separate subarrays to merge together. At that point, we return the original array, which has been modified in place by now. So that's the bottom up code for merge sort. I think I have it on the slides here also. Uh, any questions before we stop? Mario.
Yeah, so if they ask you to, well, write merge sort in an iterative way, or, well, basically like any other algorithm that is easier to write recursively, I know a way of, like writing this in an iterative way, just simulating a stack, and yeah, and do it in an iterative way with a while loop.
Yeah, so then you are actually simulating the
Okay.
recursion in an by using a stack, right? Instead of
Yeah.
um, so in that case, you are potentially using
Memory.
even more space
Yeah, space. Yeah.
because your
Well,
call stack itself would have log n activation
it would.
records. Here, notice that there is no call stack space.
Mhm.
So that's the advantage. But given how the fact that the code is a lot more complicated than the recursive version, they shouldn't be expecting this in an interview. But I'm just doing it because for the sake of completeness. I don't think this can ever be
Yeah,
asked
but
by any reasonable interviewer.
for example, in some trees problems, um, you might run if you use recursion, you might run into Stack Overflow issues, and so, well, I've seen some solutions that yeah, they convert it to an iterative way to avoid like Stack Overflow, right? So
Hmm.
is it fine in those cases to just simulate recursion using a stack on your code, or you
So
have
if
to
you,
use more?
I'm not sure that just converting recursion into a stack would cut down on the space. It shouldn't because you're just using an explicit stack for what
uh
was
yeah, but
implicit earlier.
yeah, so that's what
Unless there is like a recursion, there is a limit on how many, what the size of the call stack can be. So,
exactly.
but in terms of memory requirements, it's not really saving you space. Like in Python, you can always increase the recursion, the call stack limit.
Yeah, but the stack that you simulate is allocated into main memory, so it is limited by the memory of your computer.
Yeah,
But the call stack has normally like way lower limits.
yeah,
So,
sure.
so yeah, that's
Yeah,
why.
so if you're going to get into those system level issues, yes, having an explicit stack might give you more freedom to expand it
Okay.
to a larger
And
degree.
would it be fine for an interview in case that they ask me to, like write a recursive function in an iterative way? Would it be fine to do like the simulated approach, or?
Yeah, it should be fine. I mean, the problems that are typically asked there are more like, writing an iterator or pre-order in order post-order traversal in an iterative way, which you must have seen in the trees
Yeah.
section. I haven't seen like other um, other sort of divide and conquer algorithms being asked to be written in an iterative way, because when the recursive code is much easier, only then would you prefer the recursive code.
Yeah.
If the iterative code is more complicated, I mean, why that defeats the point of uh, asking the iterative version when the code is much easier to write in a recursive way.
Yeah. Okay. Sounds good. Thank you.
So the rule of thumb is, if the recursive code is easier to write as it is for merge sort,
Yeah.
then we always write it in a recursive way. Being aware of the limitations, but we do write it in a recursive way. So under the hood implementations might be iterative, like tim sort in Python, uh, might not be doing all this recursion. Uh, a bottom up merge sort implementation, which doesn't necessarily start at the leaf level, but maybe we can collect together, we can start from subarrays that are already large in size or almost sorted in size,
Mm-hmm.
and then merge them together instead of necessarily starting at size 1 or size 2.
Yeah. Sounds good.
Shobit?
Yeah, two quick question. So I'm just curious, are there any problems related to this bottom-up approach for on lead code?
I haven't seen. Yeah,
Okay,
I haven't seen actually. The only reason I'm doing it is because I think the official, whoever wrote the solution for that merge sorted array problem on IK, they have written a bottom up version.
okay,
And I remember some instructors, 2 years back when I joined, they used to, like, this used to be one of the problems covered in the live class.
okay.
So
And
and I've seen it on Geeks for Geeks, and also just covering it for the sake of completeness.
okay, and second question is, if we are asked to do merge sort on linked list, we will still be doing the recursive solution, and it will be an n log n solution,
Yeah,
right? Okay.
yeah.
Oh, thank you.
Okay, Bhatia.
Yeah, so I had a question. When you said second plus step size, um, that means the second step size is the second complete subarray, right? It is completely independent of the first array.
Yeah, so it's the leftmost index of the
Next partition,
next subarray pair. Yeah.
next
So the
subarray pair,
leftmost
right,
index
right,
there. So the J index, oh sorry, the
right.
J index has to be less than it. Uh,
Less than the second
Second plus
pair,
step size. Yeah. The J
right,
index
right,
starts from second and goes up what
right,
value?
right.
That's second plus step size minus 1.
Uh,
So
okay,
so it needs to be
second
less
plus,
than second plus step size. And it also needs to be less than, obviously, the length of the
right,
array, because it's possible that second plus step size might actually overshoot. This might be the rightmost subarray pair we're looking at.
right, right. And this second plus steps, second plus, what about the second pair itself? Is that coming into picture? Actually, I think the second pair comes into picture when you do first plus in the solution, the last two lines, correct? When you do in the last two lines, when
Yeah,
you do first
yeah,
plus equal to 2 into step size, second plus that, then you are now handling the second
yeah. So
pair.
we merge these two. Once
That
we
is
are done
the,
with that, then we go to
then
these.
you go to this, okay. And then when you come out of that, then you are incrementing step size itself,
Yeah, then
and
we
then you're
increment step
handling the
size
next higher level.
itself by.
Right, right. Okay. So it's this is also like a bottom up, but
Hmm,
up approach, but it's just an iterative one instead of calling
yeah,
the recursive stack. Okay.
yeah. And personally, I, I don't see why this would be asked in an interview, but just
Right.
as I said, just for the sake of
But
completeness, I'm doing it.
but won't this be more? efficient programmatically. I mean, there is no,
Yeah,
you're
yeah.
not
Programmatically, this might be because call stack. There's no call
call,
stack
yeah, yeah,
involved
there
here.
is no call stack. It's just doing it in one single call stack, everything.
Yeah.
Right.
Raghu?
Question in my mind is, do all can all bottom up recursion problems be reformulated along these lines?
Uh, Probably in principle, yes, but in practice, no. Because if you think of any, say, bottom-up DFS problem on trees, how would you go from one leaf level to the next leaf level in an arbitrary tree? Right here, it's easy because we can go from one sub problem at any level to the next sub problem at that level by a lateral move, because we know that the subarray size is the same, and so we can identify the sub problem that the next lateral manager to my right is also solving. But when we are given an arbitrary tree um, with arbitrary values and no way to get from one node to the next node on the right, at least not in a convenient way, we won't use this, right?
Makes sense. Yeah. Thanks.
Sayed? Sayed, you had a question?
Yes, sorry, I was on mute. So on the gather phase, on the second while, we have to increment the J and K also in that while.
Oh, yeah. Yeah.
Yeah, just to clear.
Uh, Key and J. Yeah.
Both should be incremented.
Yeah, thanks.
Thank you.
Mario?
No, sorry, I forgot to lower my hand.
Narendra?
Yeah, Omkar. So we have various kinds of the sorting algorithms and all, right? So is there any kind of easy way or efficient way to understand and map to the right one, like a kind of cheat sheet or something like that within the sorting algorithms versus problems? Like, do you suggest any pointers or any more suggestions?
Um, I mean, the patterns involving quicksort, merge sort, and heap sort were covered in the live class. I don't think these were completely new. The implementation might have been new for you today, right? But the
Yes,
patterns
yeah.
that I covered today were basically they were already introduced in the live class. I was just solving some problems in the practice set based on those. Although I did talk about something like horse partitioning and this bottom up approach, but uh, I think the standard solutions I covered before that should be good enough, which you probably were already familiar with. So yeah, I don't have anything to add to what is already there in the live class on the patterns. The other patterns there are many other patterns related to arrays, uh, which are there in other classes. So I can't think of anything to.
Okay.
There is actually, I mean, if I take some special classes on, let's say, the two sum series, or I know I do have to get to this topic of two pointers coming from two opposite directions in more detail. So that might be a future class once I am able to get through that material in a systematic way. Uh, so those might be a
Okay.
few missing things, but otherwise, I think the live class should have covered most of the patterns, problem solving patterns for related to sorting.
Gotcha. So the other sorting algorithms that I think not covered in live classes, but like cyclic sort, radix sort, and all these kind of other sort. So uh,
Quicksort should have
what
been
is the easy way
covered,
to remember?
but Radic sort, counting sort was covered in the
Mhm.
foundation videos, and I think in my live class slides I also have the code for them. They are not as commonly asked as they used to earlier, but so that's why we mark them as optional videos, because we don't hear
Okay.
people being asked to code up counting or Radic sort, although the code is there on the slides.
I think sometimes it might not be direct, but as we were discussing, you were suggesting to use something like to avoid the swappings or to avoid the copyings, we can go with kind of a cycle sort and all. So,
Yeah, cycle
I
sort
mean,
I've covered in
to
one of
apply
the array floaters. So
to apply exactly the right algorithm to the right problem.
mm.
Is it like more practicing in some?
Yeah, I mean that's not. I mean, if you give me a random problem with a high probability, even I might not be able to identify it quickly. So, having said that, there are some clues. Like for cycle sort, if you go through the array floaters, there's like a usually a very strong clue that it's a cycle sort problem. So, uh, yeah, there's no confusion about that there. Although hard problems can always be created on any topic. But if you haven't seen the array floaters on
Okay.
cycle sort, you can look at that. Uh, that should clarify when
Yeah.
cycle sort is to be used. Jason?
Okay. Thanks.
Hi, Omkar. That was a very good lecture. I had a suggestion. I wanted to throw it out there. I thought I heard you say at some point that there were something like 7 different graph videos, and I was looking to like a refresher on Dijkstra's algorithm. I stumbled on one video which was actually built on top of a previous discussion, and I realized that we don't sort of have an index, sort of a table of contents of all the different subjects. So if you want a refresher on a particular type of sorting or graphing problem, or Dutch flag or something, it would be nice if you had a way to just say, okay, this is the video and this is about where the discussion starts. Because some of the videos are pretty long and it's kind of hard to you may have to kind of guess which is the video, and you might be looking at a 3-hour video to try to find the right spot.
Yeah.
So I wonder what you thought about that in terms of priorities for IK.
Yeah, I can. I will keep that in mind. I'll let some of the new folks know that they should get to that. Um, yeah, I mean, I'm so obviously I may not be able to do that, but I will. I will ask other people uh, to try to prioritize it, keeping in mind that students would like it.
Yeah, it's kind of like we need like a you're driving, you need a good map. We have really great roads that you've built, but we need kind of a map to be able to jump around to different places quickly, you know.
Yeah, I mean, that's what my hope is, that as I'm building these roads, it should be easier to create the maps for someone who watches all the videos and who's tracking uh, the content here being made. So I will let the folks know in the curriculum team who
Yeah,
are trying
it'd be a
to.
big help. It'd be a big help, especially when you kind of you get into ways and you kind of forget about some of the material that we learned earlier. You know, I was trying to remember that Dutch flag, and like I solved it before, but it was a little hard to remember how I solved it. And then like if I wanted to go back, it would be you got to hunt a lot. So
Yeah. Okay. Sure. Okay, folks. It's almost midnight.
Thanks,
Okay.
Omkar.
Let me just take the last set of questions. Uday.
Yeah, Omkar. Thank you. I mean, session is really informative. I mean, as usual, it's really good. So my question is a general question. So regarding the slides sharing thing, right? Usually, ops team, they are taking. Usually, they are supposed to upload in a they mentioned that they are going to upload in within 24 hours. But sometimes we need to follow up even though after 2 days also we are not getting. So
Okay, I will let them know I'm uploading it right away. So
yeah, already
they should have it right away. So
right.
if, yeah, you
Yeah,
could.
because
Hmm.
once this session is done, so tomorrow if I want to quickly refer while
Hmm.
doing the coding, then it will be very helpful if I have that, or at least after a day.
Sure, yeah. I think they should be able to upload it in a day. Uh, you're talking about the video or just the slides?
Slides is good enough. Even if video is not possible, at
Okay,
least slides is good enough.
sure. As I'm speaking, I'm just sharing it with them.
Yeah,
Uh,
but nowadays they put slides with video. There are no separate slides.
there are no separate slides.
Yes, slides are part of the video now.
Oh, okay. I'm not sure what that means. You mean,
Means there are no earlier they used to have separate slides and video, right? So
hmm,
now they have combined together.
I see.
Yeah. But it's okay. But I had a question. What is your plan now? Means you are going to do this homework problems from all the sections, or this was just for this?
Just for this, since um they requested me to do this for. So there is another person who is going to be doing it for the other classes. Another somebody they hired full time.
Yeah.
So I think he's starting to take the test sessions and he'll be getting to the uh, problem sessions also.
Okay. Yeah, that will be good. Thank you.
Okay.
Yeah.
Uh,
Thank you, Omkar. Thank you.
Thanks,
sure.
Omkar.
Thank you all. I'm just done. I'm just dealing with the last few questions here. Who? Uh, Sorry, I can't see the names. Vasan?
Okay, your Discord ID, what is it? I don't know. I sent you an email today afternoon.
Yeah, I got your email. I haven't solved
Oh,
that
thank you.
problem.
That's
That's
fine.
why I
Now I
couldn't.
got it. I don't have to bother on Discord.
Sure. Yeah,
Thank
I
you.
did get your email.
Thank you.
I haven't solved that problem. That's why I may not be able to reply back immediately.
No, that's fine. That's fine. There's a solution, but it's not matching into. It is a difficult solution. I cannot even intuitively think about it. It's too many.
Okay.
Even forget about C. I cannot even implement that in C. In Python, it is there, but it doesn't fit to the pattern that we see either in graphs. It's all confused.
But did you take it to coaching session, technical coaching sessions?
Sorry.
Did you?
So technical coaches usually are supposed to help with random problems from read code.
Yeah.
Have you tried it with them?
No, there is a solution. The problem is it's more to do with the way you pattern it, right? It's to
Okay.
do with that. It's not. I have the solution. That's why I mentioned clearly in the statement that there is a working solution, but it doesn't. There's no. It's not a smooth flowing solution.
Mm-hmm.
Just very
Yeah, but
jarring.
if you
What's the
take it,
problem number? Just curious. Sorry.
It's
yeah,
a line transform from matrix.
Seleni, question?
Yeah, I was just curious, since we're talking about reviewing some of the materials from early on, are we allowed to participate on the lectures for the new cohorts?
I think you have 2 makeup classes, right? So you can attend 2 of the classes. You can just check with operations what the policies are. From what I remember, 2 makeup classes you're allowed to attend with the new cohorts.
For the new cohort?
Otherwise, you can always get the recordings of any instructor that you want for any class.
Yeah, no, I know that. But I just thought that, I just find a live class, you can ask more questions and stuff. So I just, I don't see any new classes on the schedule there. So I assumed we did it. But I guess we have to ask to be notified when they have and ask to participate then. That's what you're saying.
Uh, yeah, I mean, the classes that I'm taking are sort of impromptu, so
Yeah.
they may
So
not
you're,
provide advance notice for it, but every month there are 2 or 3 floater sessions that happen, concurrency, strings, and ad hoc and topics like that. So those keep repeating.
yeah,
Uh,
I've attended a lot of those too.
yeah, and then technical coaching sessions, of course, are available every day.
Yeah, absolutely. So, yeah, thank you, Omkar. This
Sure.
was very good again. So,
Thank you. Abhishek?
Yeah, Omkar, quick question. So, do you have any arrays floater session before from previous years, or is it just
No,
the arrays?
I just did them recently in December.
Okay, okay, yeah.
Yeah.
Thank you, Omkar.
Narendra, last question.
Yeah, a very quick question, Omkar. Related to generic. So there are a lot of technical sessions and system design coaching sessions are happening, right? So is there a way these are being recorded and we can refer those if we are checking for similar kind of problem?
Which sessions are you referring to? The technical coaching?
Individual TC, technical coaching and system design coaching sessions which are happening daily.
So I think operations. So Soham, you have to ask Soham for it, but because I think he has a strict policy that you have to attend those sessions live, and that if you
Okay.
so recordings are not. Um, as a
Does it?
policy, they don't give the recordings for technical coaching sessions
Yeah,
to
because
encourage people to attend them live and ask their questions live.
if the problem is same, it might be repeatedly taking the effort from the instructor and the individual instructor especially, right? So
Yeah.
maybe some cases it might be useful to just refer if it is already being solved on a similar scenario, right?
Yeah.
Maybe.
Yeah. I mean, you'll have to
But
make that
currently,
case to him.
currently,
Hmm. But because I
currently,
think
this.
the idea is that since this is technical coaching sessions provide an important live component for the program, they don't want to start if they start giving recordings, then it undermines the value of the live component. So I think that's why they made that decision on the
Okay.
operations side.
Okay, get you.
Again, I'm not.
And
I don't control those decisions, so we'll have to
yeah.
basically ask him. Maybe he might heed to individual requests on a case by case
Yeah.
basis.
Just checking if there is a centralized place where we can search for all the earlier technical coaching sessions. That's my recommendation. Yeah, but that's fine. Like whatever you said, maybe I'll give as a
Yeah, I mean,
suggestion
things
to
can
the.
change. Right now, they've started
Yeah,
making recordings for the problems. So the idea is to provide as much self-help as possible. So since
right.
the policy, seems to be fluid, so best to check with him on what the
Yeah, sure. Thank you.
latest is.
Thanks a lot, Omkar. Yeah, thanks for your time today. It is really helpful.
Sure. Thank you all.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today